All right, for 5.1, solving systems of linear equations by graphing. Okay, systems of equations. Don't get intimidated by that. A system just means more than one equation. So below here, you can see that we have two equations that we're working with. All right, now tell whether the ordered pair is a solution of the system. All right, now in order for this ordered pair to be a solution to this system, this group of two equations, when you plug in the x and y values, it has to work out to be true for each equation. So let's see. For part A, I'm going to plug in the x value for the first equation, plug in the y value for the first equation, equals 7. I have 2 plus 5 equals 7. I end up with 7 equals 7. That checks off. That's true. For the second equation, I'm going to plug in 2 for x, plug in 5 for y. All right, let's simplify everything on the left side here. I have 4 minus 15. All right, and then I have 4 minus 15 is negative 11. That checks off to be true. So your answer is yes. The ordered pair is a solution to the system. It's as simple as that. All right, let's do the same thing for part B. All right, going to plug in the x value, the y value first. For the first equation, I have 0 equals negative 2 times x. X is negative 2 minus 4. I have 0 equals 4 minus 4. I get 0 equals 0. That checks off to be true. Let's see if it also works with the second equation, because it has to work for both, not just one. All right, so I have 0 equals negative 2 plus 4. I get 0 equals 2. That is not true. Okay, so your answer in this case is no. The ordered pair is not a solution, because it has to work for both equations. All right, let's go on to another example. Solving a system of linear equations by graphing. All right, so first thing you need to do is graph the equations. Then you need to estimate the point of intersection. And then to determine if that point is actually a solution, if you determine the right point, then you just substitute it back in and see if it works out to be true, like we did in example 1. So both of these equations are already in slope-intercept form. Perfect. So I'm going to label this equation 1. I'm going to label that equation 2. So for equation 1, my slope is negative 2 over 1, and the y-intercept is 5. For equation 2, my slope is 4 over 1, and my y-intercept is negative 1. All right, so let's graph the first equation. I'm going to go up 5. And from there I go down 2, right 1. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then up 2, back 1. All right, so there's that first line. And then for the second equation, my y-intercept is negative 1. And then from there I apply the slope. I go up 4, right 1. Up 4, right 1. Down 4, back 1. And you want to be as accurate as you possibly can when graphing lines. All right, it's a little hard to be super accurate on the iPad, but you can see right here that this is where the lines cross. What is that point? That would be 1. And is it up 3? Yep, up 3. All right, now to verify if that's true, let's go plug it in to each equation and see if it works out to be true. So plugging it into the first equation, I have 3 equals negative 2 times 1 plus 5. So simplifying both sides, I get negative 2 plus 5, and I end up with 3 equals 3. Cool, it works for the first equation. How about for the second? Plug it in, I get 3 equals 4 times 1 minus 1. So I get 3 equals 4 minus 1. 3 equals 3. Checks off to be true there too. So we definitely know that 1, 3, the point, is a solution to the system. So 1, 3 is my solution to the system. And I figured that out by graphing. All right, the last example. All right, these are quite challenging here. Okay, it's a word problem. We're going to have to put together a system of equations. So let's see how this breaks down. A roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. Right, in his second purchase, at the same prices. The contractor buys 8 bundles. All right, this is for the second. 8 bundles of shingles for $256. Find the price per bundle of shingles and the price per roll of roofing paper. Okay, so price per bundle of shingles, we'll call that X, and the price per roll of roofing paper, we'll call that Y. Okay, so how's this going to work? All right, well, going up to the information in the beginning, we have 30 bundles of shingles, 30. And I don't know how much the bundles cost, all right? But that's what I'm trying to figure out. That's X. So 30 times X would be the total cost for the shingles. Then I have plus, let's see, I have 4 rolls of roofing paper. All right, so 4 rolls of roofing paper. I don't know how much the roofing paper costs, but the variable Y is associated with the cost of roofing paper. All right, I know together the total cost for the 30 bundles and 4 rolls is $1,040. All right, then we have a second purchase. The contractor buys 8 bundles of shingles. All right, 8 bundles of shingles. All right, now shingles, we have the variable X associated with that, the price per bundle, so that's X. And I know the total cost of that is $256. All right, so this is the most challenging part here. If you did this, then that's more than half the battle of solving this problem. All right, putting together the system. So at this point now, how do you solve the system? Well, you could graph. All right, now this is a little difficult to graph on paper since you're working with big numbers here. So you would graph it on a graphing calculator. But what if you didn't have a calculator or you didn't have a grid to graph it? Well, here's one approach, and we'll be learning more about this in future lessons. I'm going to solve for X right now. I'm going to divide this by 8. So X is equal to, well, how many times does 8 go into 256? All right, goes in there 32 times. Okay, so X represents the price per bundle, so it's $32 per bundle of shingles. All right, now that I have X, I could plug it into the other equation and solve for Y. So let's do that. So I have 30 times 32 plus 4Y equals 1,040. All right, so I end up with 30 times 32, which is what? 960. All right, subtract 960. I get 4y is equal to 80. I divide by 4, and y is equal to 20. All right, so it's $20 per roll of roofing paper. All right, we've answered the question. All right, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.